Hi, good morning, everybody. Today I thought I'm gonna start a day by doing a derivation regarding Leibniz rule. So, why would I do this? Right? It's a normal morning, and just suddenly this is due coming off and told you to do such derivation. It doesn't make any sense, right? So the reason why I do this because one day you need a better tool of doing integration. So right now need better tool to do integration. First thing. Second thing, you need to differentiate special function. Differentiate special function. Okay, so what does it mean? It means that in order to understand Leibniz rule, you need to understand integral and derivative. Okay, now let's go ahead and see what it means, what's the definition, and how to calculate it. Okay, so let's say you have a function I, and your function I is a function in terms of alpha. Okay, and this is being defined as the integral of a alpha to b alpha of f x alpha dx. Okay, the question how do you calculate? How do I calculate di over d alpha? Okay, well, this seems like a very simple question, right? However, in fact, it's not that simple at all, because you see, usually hard math problem, the question is not that bad, but the way you get to answer is usually very subtle, and it contains a lot of build of knowledge. So today I'm gonna actually tell you how to calculate this, and then see how can we apply this into solving hard derivative or integral problem. Okay, so in order to calculate this, you need to recall the definition of derivative. So di over d alpha, right? What does it mean? It means that you do limit delta alpha to 0 of I alpha plus delta alpha minus I alpha delta alpha, right? This is the definition. So in order to calculate this, I will attempt to calculate this limit. Okay, because this is the same thing, and this one, it seems to be more apparent. Okay, so small step A. I'm gonna calculate. Oh, calculate is the wrong word. There's no number here. Bad news for engineers. I'm gonna simplify. Okay, I think this is the best word to use. Simplify this. Okay, so I alpha plus delta alpha equal A alpha plus delta A, B alpha plus delta B of f x alpha plus delta alpha dx. Okay, you agree with me? Cool. So I alpha plus delta alpha minus I alpha. I'm gonna highlight this because this is our main goal right here. Okay, what is equal to? Equal to A alpha plus delta alpha. I'm just gonna copy it down because I already determined it right here. I'm gonna copy this term down. So integral of f x alpha plus delta alpha dx minus A alpha B alpha. Oh, alpha. It's not x, it's alpha. It's like a fish. Times f x alpha dx. Okay, now I'm gonna rewrite this a little bit. Okay, you ready? I'm gonna rewrite this term right here a little bit. I'm gonna add, minus, distribute a little bit. Okay, so this one will be equal to A alpha plus delta A A alpha f x alpha plus delta alpha dx plus A alpha B alpha f x delta plus delta alpha dx plus B alpha P alpha plus delta B. Okay, and then you minus this term. So wait, let me fill it up. Minus A alpha B alpha f x alpha dx. Okay, so far so good. Okay, so now the next step is I'm gonna group this term with this term. Okay, so I'm gonna rewrite the first two terms. F x alpha plus delta alpha dx plus bx alpha. So, oh my god, I got confused too. Plus delta b f x alpha plus delta alpha dx plus A alpha B alpha f x alpha plus delta alpha minus fx. Okay, dx. Okay, now I'm gonna change the sign a little bit here. So if you want to change the what do you call it, the boundary, you just change the sign. So this is negative A alpha plus delta A f x alpha plus delta alpha dx plus integral of B alpha plus delta B f x alpha plus delta alpha dx plus A alpha B alpha f x alpha plus delta alpha minus f x. Oh my god, I forgot something. This should be f x alpha. Two variable. This is function two variable. dx. Okay. Now, so in the next video, I'm gonna plug in the limit and see what we arrive. Okay. Thank you for your attention. And I hope this makes sense so far. So basically all we did is we add in the integral. So yeah, so basically what we did is we do this. So for example, if this is 0 to 1 fx dx recon. Not 0 to 1, I can put it 0 to like 4. You can do 0 to 1 fx dx plus 1 to 4 fx dx. So 1 to 3 fx dx plus 3 to 4 fx dx. Yeah, that's basically what I did. That's why we arrive at this, and I group the two blue terms together, and then yeah, and then I group them, and then I change the sign. That's it. So in the next video, we're gonna plug in the limit and see what we arrive at. Okay, thank you for all your attention.